Find the V out over V in voltage gain ratio for this circuit for the scenario that switch that is shown here is open versus it is closed. Okay, as you can see, there are two ideal op amps in this circuit. We are making the assumption that they are properly biased. So we are making the assumption the op amps are not saturated in linear region of operation, and therefore virtual short is valid. By virtual short, we are saying that V positive at the input terminal of the op amp is equal to V negative for each of the op amps. So that is the meaning of virtual short. Now, let's consider the situation where we have switch open, as it is shown here. When this switch is open, we can see that Vn is connected via CVs of R and R to positive input terminal. Because op amp is in linear region op amp number 1 and not saturated, and we are assuming it's properly biased with negative feedback, there is no current that can flow through the input terminal of op amp with infinite impedance. So that current is 0. Therefore, this Vin appears exactly at positive input terminal. Because of virtual short, therefore, we should conclude that that same voltage Vin appears at the negative input terminal as well, because positive and negative have the same voltage. So, what is the impact? Since on both sides of R1 we have the same voltage Vn, no current can flow through R1. As a result, no current continue flowing through R2. As a result, output of op amp number 1 is Vin as well. Okay, so we get to, therefore, for the switch open scenario, I would say if I name, let me show you here, if I name this node V out, Vx, let's say, output of op amp number 1, I concluded that Vx should be equal to Vin. Okay, so the circuit now is simplified to this situation that we have for the second op amp. Basically, we have Vx at the input of second op amp, and then we have R, then we have R, and then it goes to positive input terminal of the second op amp. Negative input terminal from Vin or Vx is connected via R, and then we can see via 2R we are going to, so let me just make sure that you can see it. Okay, so I am going to show it better. VR, okay, and then here is the second op amp plus minus, and this is the final output. Okay, this is not difficult. We can see Vx, which in this case switch open is Vn, as I explained. Here, give you Vx over 2, and again, because op amp number 2 is also not saturated in linear region, virtual short should be valid, so Vx over 2 also appear at negative input terminal. Now I can just write a very simple KCL. Basically, I am going to say that the current that passes through this resistor should be the same current that passes through this resistor going to output, because nothing can go through to the input terminal of an ideal op amp because it has infinite impedance. So if I write that KCL, it becomes Vx minus Vx over 2 of the current that goes through this R divided by R should be the same thing as the current that goes through 2R, which is Vx over 2 minus V out divided by 2R. So obviously R and R cancel from both sides, and we get Vx over 2 equal to, so we started with Vx over 2 and then Vx over 2, and we continued with Vx over 2 minus V out over 2R. So what we get is Vx over 2 equal to Vx over 4 minus V out over 2. Or I could just simply multiply both sides by 2 and then simplify it, so it becomes something like this. And if I continue this, so let me just make sure you can see it. I am going to shift this one here, because I see that you might not be able to see it. Now you see it. Okay, so as a result, what we get is, in this scenario, V out is obviously negative Vx over 2. So whatever for the second op amp, whatever appear at the input of second op amp, which is Vx, then output becomes negative Vx over 2. Basically, second op amp with the kind of circuit that is around it, realize just a gain of minus 1 over 2. So just have that in mind, that gain of the second op amp is just minus 0.5 effectively voltage gain. Let me just write it here. Obvious. So gain of second op amp is negative 0.5. Okay, so in that scenario, because effectively the gain of first op amp is 1 and the gain of second op amp is negative 0.5, so for the switch open case, in summary, when the switch is open, the total gain is gain 1 times gain 2, which means the total gain is just basically minus 0.5. Okay, now let's switch to the scenario that we have this switch here closed. So switch closed. If the switch is closed, what's going to be the case is now you close this switch. Therefore, this node is now grounded. So as a result, positive input terminal of this op amp number 1 is connected to ground. And again, we are making the assumption that virtual short is valid. So positive input terminal becomes 0. So I'm going to show it here. So when we have switch close, we have positive input terminal grounded. And then negative input terminal also would end up having 0 voltage, but then connected via R, as you can see, to Vn, and connected via R1 to Vn, and via R2 to Vx. So it's a standard, in that scenario for the op amp number 1, it's a standard inverting amplifier, and we know that the gain 1, or gain of op amp 1, voltage gain of op amp 1, which is Vx over Vn, is simply negative R2 over R1. So that is gain of op amp number 1 in this case. So let me switch the color. Okay, so now we are again at Vx, which is basically output of op amp 1, which means we get back to the same situation we have here, because the setup around op amp number 2 is like before, it hasn't changed. So we still have gain of op amp number 2, negative 0.5. Therefore, for switch closed scenario, what we have is again gain is gain 1 times gain 2, and in that case is obviously negative 0.5 times negative R2 over R1. So just it is 0.5 R2 over R1. Okay, what the question is, now that we found the gain for the voltage gains for both scenarios, the question is asking what is the ratio of the voltage gain for switch open to switch closed modes. Okay, fine. So I'm going to therefore divide this outcome by this outcome. So the total answer is let's say the ratio is minus 0.5, which I found from here. So I'm going to use this value. Divide by this value. So 0.5 over R2 over R1. Effectively, it means, since we are interested in voltage gain ratio between the two modes, the second op amp is not an important factor for us. The only reason I went through presenting also the gain of second op amp is an exercise. Otherwise, if you really just want to find the voltage gain ratio between these two modes, you don't need to deal with the second op amp. So as you can see, the outcome of this investigation, obviously, let me use a different color. So the final answer to this problem therefore becomes this answer. So as a result, the ratio obviously becomes negative R1 over R2. The ratio of the voltage gains, comparing this situation that is switch open to switch close. I hope that this example is helpful.